Hello everyone. In earlier videos we have seen how to find out arc length when we have given Cartesian curves, that is either y as a function of x or x as a function of y. If you have not seen that, then please go through those videos first. In this video we are going to see how to find out the arc length of the curves which are given in the polar form, that is we have given r as a function of theta or theta as a function of r. So whenever r is a function of theta, then we can use the formula s is equals to integration square root of r square plus dr by d theta the whole square d theta, and theta varying from theta 1 to theta 2. If we have theta as a function of r, then the formula is s equals to integration square root of 1 plus r square d theta by dr square dr, and the limits are r1 to R2. So let us see few examples related to the polar curves. So now let us solve problems of rectification related to the cardioid. So the first problem is find the length of the cardioid r is equals to a into 1 plus cos theta, or r is equals to a into 1 minus cos theta, whatever it is. The procedure will remain same, only the diagram is different, and prove that the upper half is bisected by the line theta equals to pi by 3. So let us first find out the length of the cardioid or the perimeter of the cardioid. So first of all, let us draw the cardioid. So we have x-axis and y-axis here, and whenever theta is 0, that is whenever the angle is 0, cos theta is 1, so obviously we will get r as 2a, and for theta is equals to pi by 2, cos pi by 2 is 0, so we will get r as a. So I think we can easily identify from these 2 points also the shape of the cardioid. So obviously the cardioid is of this shape, and then we need to find out the length of the cardioid. So let us try to find out that using the formula which is given in the polar form. Here we have given r is equals to a into 1 plus cos theta, that is r is a function of theta. S is equal to length of the cardioid, which is equal to, now we can clearly from the diagram we can see that the cardioid is symmetric along x-axis, so it is absolutely okay if I find out the length of only upper half of a cardioid. So suppose this is origin, this point is origin, and this point is A. So here I'm going to find out length of OA. So length of OA, and then twice of that will be the complete length of cardioid. So let us concentrate only on the upper half of the cardioid. So here, as r as a function of theta, we will use the formula of rectification, in which dr by d theta term is there, because here it is easy to take a derivative of r with respect to theta. So let us use the formula in which we have dr by d theta. So integration square root of r square plus dr by d theta the whole square d theta, and here we are going to write down the limits of theta 1 and theta 2. So this is equal to 2 into integration of square root of r square plus dr by d theta square d theta, and here we are going to write down the limits of theta. Meaning of that, we need to write down the limits of angle in which the curve is bounded. So we just need to see that the end points of the curve lying on which line, and we have to find out the angle of that line. So here we have O is lying on negative x-axis and A is lying on positive x-axis. So the angle that we require over here is, obviously we will consider the anti-clockwise direction only. So here first we will write down the angle of the line on which A is lying. So A is lying on positive x-axis, and the angle of positive x-axis with itself is 0. O is lying on negative x-axis, and the angle of negative x-axis with the positive x-axis is pi. So the limits that we are going to use over here are 0 to pi. Let us call this equation as 1. Let us first find out dr by d theta from the given curve. So as we know, r is equals to a into 1 plus cos theta. Dr by d theta is equals to a is constant, derivative of 1 with respect to theta is 0, and derivative of cos theta is minus sin theta. So we are getting the answer over here as minus a sin theta. We require in the formula dr by d theta square. So dr by d theta the whole square is equals to a square sin square theta. Then we require r square plus dr by d theta the whole square value. So this is equal to, now the r square is nothing but a square 1 plus cos theta the whole square from the equation that we have r is equals to a into 1 plus cos theta plus dr by d theta, the whole square is nothing but a square sine square theta. From this we can take a square common. Let us solve the bracket 1 plus cos theta the whole square, which is 1 plus 2 cos theta plus cos square theta plus sine square theta. We know that cos square theta plus sine square theta is 1. So we will get here the answer as a square 1 plus 2 cos theta plus 1. So this is equals to a square 2 plus 2 cos theta. Here I can take 2 common, so that I'll get a square into 2 into 1 plus cos theta. And we know that 1 plus cos theta is nothing but 2 cos square theta by 2. So here we will get answer as 4a square cos square theta by 2. We require in the formula square root of r square plus dr by d theta square, and that is equal to 2a cos theta by 2. So let us substitute everything in the formula. So we have the formula as 2 into integration 0 to pi square root of r square plus dr by d theta whole square d theta. Let us use that. So from 1, s is equals to 2 into integration 0 to pi square root of r square plus dr by d theta the whole square d theta. So this is equals to 2 into integration 0 to pi 2a cos theta by 2 d theta. Here 2a is constant, so we can write it as 4a, and the integration of cos theta by 2 is sine theta by 2 upon 1 by 2 d theta with the limits 0 to pi. Let us substitute the limits now. So we will get 4a, this 2 will come up and we will have first term as sine pi by 2 minus sine 0 is 0, so we'll get the 0 as the term over here. So this is equal to 4a into 2 sine pi by 2 is 1. So the final answer that we will have here is 8a. So 8a is nothing but the perimeter of a cardioid, or you can say that length of the cardioid. So first part is done. In the second part we have in the question, prove that the upper half is bisected by the line theta is equals to pi by 3. Pi by 3 is nothing but the 60-degree angle, so it will be somewhere over here. So this is clearly theta equals to pi by 3. Suppose this point is B, then I want to prove that the upper half is bisected by this line theta equals to pi by 3. That means length of AB is equal to length of BU. So let us prove that. So for this what we will do, we will just find out the length of AB and we will prove that it is exactly half of the length of OA or AO. So to find length of AB, so therefore length of AB is equal to, now we are finding length of cardioid only, so we have to use the same formula theta 1 to theta 2 square root of r square plus dr by d theta the whole square d theta. So we need to just write down here the limits of theta properly. So we have to just see that where this points A and B lying. So clearly A is lying on positive x-axis and B is lying on theta equals to pi by 3, and B is lying on this line whose angle with the positive x-axis is pi by 3. So we know that as A is lying on positive x-axis, the angle will be 0, and we know that the angle of the line passing through this B is pi by 3. So here the limits of theta are 0 to pi by 3. So 0 to pi by 3 square root of r square plus dr by d theta the whole square d theta. We know the value of the square root of r square plus dr by d theta the whole square, which we are going to directly substitute over here, which is 2a cos theta by 2. So this is equals to integration 0 to pi by 3 2a cos theta by 2 d theta. Then 2a is constant, integration of cos theta by 2 is sine theta by 2 upon 1 by 2 with the limits at 0 to pi by 3. So this is equal to 2a into, this 2 will come up, it will be sine pi by 3 into 2 minus, if I substitute 0, sine 0 is 0, so whole thing will turn out to be 0. This is equal to 2a into 2 sine pi by 6. So the answer is 4a. Sine pi by 6 is nothing but sine 30 degree. Sine 30 degree is half. So we will get the answer is equals to 2a. So this is the length of AB, as S equal to length of cardioid is equal to 8a. So Therefore, length of upper half of cardioid is equal to 8a by 2, because we know that the cardioid is symmetric along x-axis. So the upper half and the lower half of the cardioid is exactly same. So we can write here 8a by 2, and that is equal to 4a. And we are getting the length of AB is exactly 2a. So as length of AB is equal to 2a, which is exactly half of length of upper half of cardioid, that implies upper half of cardioid is bisected by the line theta equals to pi by 3.